I want to start by asking you, how do we know that the universe is expanding?
How do we know? That's a good question. In fact, we're coming up to a century of us knowing that the universe is expanding. So that it was that time in the early 1900s where there was an advancement in theory on one side and observations in the other, and they came together at the end of the 1920s. So on the theory side, you had Einstein and Friedman and Lemaitre, who were working with the equations of relativity to try and come up with a mathematical model for the entire universe. And there was a bit of to and fro there about, did we live in a static universe? Did we live in a changing universe, etc.? But on the flip side, we also had Edwin Hubble working in the US, of course, and he was measuring the velocities of galaxies around us. And we tend to forget that the realization that there are separate island universes, as they call them, they're separate galaxies to our own, was still a new idea in the 1920s. And so there was Hubble's observations. He was measuring the velocities of galaxies, expecting them to be basically buzzing around. But what he found is that galaxies were moving away from the Milky Way, and they were moving away from us faster and faster the further we looked at these galaxies. And that precisely matched the predictions that were coming from the theory side. So like in the 1920s, it all came together at the right time, that there was the mathematical framework and then the observations to back it up that showed that we live in an expanding and evolving universe.
So I want to expand on that point, no pun intended, is that he saw the galaxies moving away. How did he actually know that they're moving away? How does one figure out that an object is receding?
So the same way that the police catch you speeding your car, right? I mean, what he was using is the Doppler shift. So the Doppler shift had been worked out, a couple of centuries before in relation to sound. And so this is something that we're all familiar with. You hear an ice cream truck, or you hear a police car, as it's coming towards you and then going away from you, you get that change in pitch with regards to the sound. So coming towards you, what you would say with regards to sound is that sound waves get compressed and our ear picks that up as a higher frequency. And as the car is driving away from us, the waves appear to be stretched out, and so you get the frequency drops. And the same thing happens with light. So if you have a source of light and it is moving either towards you or away from you, you either get a compression of the waves, so they go up in frequency. So we would call that a blue shift, i.e. waves are becoming shorter, so moving towards the blue end of the spectrum. Or if they're moving away from us, the waves are being stretched out, and we call that redshift. And that's the tool that was first used on stars in the Milky Way galaxy to measure their velocities. So you could basically see how stars were moving from their Doppler shift. So you basically compare the spectrum of light you get from that star to what you would get in a laboratory, and you see all the lines move either one way or the other. And what Hubble did is he took that to the question of entire galaxies. So he starts off with the nearest galaxy, basically, which is Andromeda, 2 million light years away, found that it has a blue shift and it's moving towards us. But then as he was looking out at other galaxies, okay, so the more distant galaxies, he found that they had redshifts. And then the more galaxies he got, he found that every single one of them effectively was moving away from us. And importantly, for the predictions from Einstein's equations, and it was Lemaitre who was the one who had this key insight. What he found is that if he plotted a picture of the distance to a galaxy versus its velocity, he found this relationship that the further away they are, the higher the redshift, and so the faster the galaxy is moving away from us.
So I actually wasn't familiar with that part, that Lemaitre was the one who suggested that plot. I always thought that Hubble was the one that made the plot and fit the line, and then it became known as Hubble's law.
Yeah, so Hubble did make that plot, but it was Lemaitre was the one that realized what the plot was telling us. So this is one of the interesting quirks of history, is that it appears that Hubble never really embraced this expanding universe kind of picture. And so he had found the relationship, and he always thought well, there's something else going on, not this expanding universe stuff. But it was Lemaitre that really pulled the pieces together. And I'm not sure if you know that a couple of years ago, the Hubble relationship or the Hubble law became the Hubble-Lemaitre law. Hubble for the observations, Lemaitre for the theoretical insights about what it was actually telling us.
I actually was not familiar with that. When I took cosmology, which was almost 4 years ago, it was still called Hubble's law, and the Hubble parameter. Everything was named just after Hubble. But it's good to know that they've updated.
Yeah, and again, this is one of the things that I find more interesting as I get older, is that if you look at the history of science, it's always so much messier than the textbooks lay out. And there was this whole kerfuffle around. Lemaitre originally published his papers in Belgium, I think it was, and eventually, and in there he had this particular relationship, Hubble's laws relationship, and then he was asked to do a translation for the monthly notices of the Royal Astronomical Society, where some of the key stuff had been removed, and there was this conspiracy theory that it had been removed by one of the editors, and it turned out it was Lemaitre himself that decided he didn't want that particular piece of stuff in there. So it's whenever you read a textbook, I advise you should always go and try and find a little bit of history just to see how messy and confusing everything actually was at the time.
That's really good advice. It's almost always more than one person involved.
Always. Even in the Hubble story, Hubble is the one who's remembered for those observations, but there was also another astronomer, Slipher, who was the one who actually did a lot of the velocity measurements. Hubble's key insight was measuring distances. So again, people seem to disappear from the history books. From the textbooks. They're in the history books, but not necessarily in the physics textbooks.